Also, with these trig functions and some of the concepts we use to develop them, we also come up with another way of figuring out the area of a triangle under a very special circumstance. Now, we're used to the formula area equals 1/2 the base times the height. Most students remember that from geometry, even some algebra courses go over that again and again. So, this is probably a formula that's not unfamiliar to you, and it's probably the most common way that you're used to finding the area of a triangle. However, if I'm given a situation like this where, I know two sides of the triangle and I know the included angle, if I was to construct where the height would be, I would say, well, the height would be about here. And that would form a right triangle inside this bigger triangle. I mean, that's what the height would be. It's always perpendicular to the base. And here I'm letting the base be B as usual. For the formula we had 1/2 base times height. But I can also look at the right triangle formed on the left-hand side and say, well, wait a second. I know that the sine of theta equals the height over A, because A would become the hypotenuse of that little triangle, which means that the height is A times the sine of theta. Well, because of that, I can substitute that in over here and get that the area is 1/2 the base times A times the sine of theta, or come up with the formula at 1/2 AB sine theta. So you may see some textbooks also give you a second formula for the area of a triangle, either being 1/2 AB sine theta or 1/2 AB sine of C. The important characteristic you have to keep in mind, though, is that it does involve two sides of the triangle and the angle, but that angle has to be the included angle. It's just not two sides in any angle. The most common mistake that students make on this is that they'll see that they have two sides in an angle. That angle may not be the included angle, but they still use this formula to come up with an answer, and that answer is wrong as a result.